Yes, sir. Hello.
Hello.
Mr. Vijay, am I audible?
Yes, you are audible. Yes.
Yeah. Sorry for the delay. Just a minute, I'll share my screen. Yeah, I hope my screen is visible.
Yes. Yes, it is.
So, yeah. So, very good morning to everyone. This is Venkat from Genetics Coimbatore. So, first of all, on behalf of Genetics and Farming Technology, we welcome you all to this webinar. So, we have Mr. Vijay from Farming Technology to deliver the webinar today.
Yes.
Just, yeah. So, Genetics is an Indian manufacturer of automation products. We provide products, systems, and solutions for various industries. And also we offer didactic systems for academia for technical education. So we established in the year 1977, and our R&D division is approved by DSIR. So we have an in-house tool room facility for tool and die making. Genetics is an integrated manufacturing system certified company. It also includes the QMS, EMS, and OHS. So we have a pan-India service facility. So India Genetics have 15 plus branches in India and 3 overseas offices located in USA, Germany, and Dubai. We have 200 plus support engineers globally and 150 plus dealers and stockists. So we have 1,000 plus OEM, EMS, and about 17,000 plus direct customers. So Genetics is the authorized distributor for automation studio in India. So our central manufacturing facility is located in Coimbatore. So today we have a series of webinar planned on different topics for this month. And today, on May 18th, we are going to see the advanced hydraulics. And and if you have any questions related, please write in the question box, and we will sure address your questions. Now I'll welcome Mr. Vijay to start the session.
Okay. Thank you, Sunil, for a
Vijay,
brief
now you can,
introduction.
yeah.
Yes. So I'll share my screen. Yeah. I hope my screen is visible.
Yes, Vijay, your screen is visible.
Okay. Yeah. So for topic for today's webinars will be component modeling, pumps and proportional valves specifically, actuator components and load impacts, mobile hydraulics, some functions like flow, pressure, torque control, optimizing system design through manufacturer's catalog. We will look into 3D manifold block creation and simulation. So if some of demo files like wheel loader and excavator, and in the end we will have a question answer session. So before going through the webinar, let me briefly introduce our company. So we are more than 130 engineers and software specialists. We are an ISO certified company. We were founded in the year 1986. We have our headquarters in Montreal, Canada, with branches in Mannheim, Germany, and Pune, India. We are leading the industry by designing world-class trade-oriented tools in the field of fluid power, electrical engineering, industrial automation, and custom software development. We have in-house expertise in the field of software development, engineering, and industrial automation. Under software development, we have engineers working on database design, network support, multimedia applications, object-oriented web-based applications, real-time systems. Under engineering, we have engineers working on CAD CA systems, pneumatic systems, hydraulic systems, mathematical modeling, electrical systems, automation engineering, instrumentation and process control, training. Under industrial automation, we have people working on PLC programming, SCADA systems, human machine interface, electrical controls, process simulation, system maintenance, and so on. These are the products that FAMIC offers. We have Automation Studio Professional Edition, generally used by industrial clients to create, troubleshoot, analyze their multi-technology circuits. Then we have Automation Studio Educational Edition, which is generally used by technicians, technical institutes, educational institutes, to train their students on hydraulic, pneumatic, electrical, PLC systems. Then we have AS Manifold Live, wherein you can create 3D manifold and analyze it through simulation. And then we have Automation Studio and on Studio, uh, which is more related to plant management and Industry 4.0. We believe in on maintaining long-term relationship with our customers, provide effective community support, provide dedicated representative for each user accounts, and we keep updating the support material, wherein we provide training videos, demonstration files, quick start guides, etc. Here are some of the milestones in the history of FEMI Technologies. Founded in the year 1986, we were known as NeoSim HydroSim, which was multimedia version of a software. In the year 1996, we switched to a Windows-based platform by launching our product as Automation Studio 1.0. Since then, we have a series of iterations. At present, in the year 2022, we also launched Automation Studio 7.1 version with many high-end features like web-based catalogs, document display standards, didactic libraries, ladder diagram, Mitsubishi faster simulation for larger projects. Automation Studio provides you multi-user platform, so you can use it for trade-oriented system design, analyze it through simulation, and use it for multi-machine documentation. We work on different technologies, fluid power, which includes hydraulic block manifold, pneumatic, and some part of mechanical. Then electrical, which includes electrical engineering, electrical AC/DC motor control, electrical one line, electrical control block diagrams, and automation, which includes OPC, PLC, APIs, SFC. The software also provides you tools to create certain documentation like bill of materials and other kind of project reports. It also has features related to the manufacturer's catalog, which I'll be telling more in the later part of the webinar. You can also have control panels, 2D, 3D HMI, digital electronics, teach when, and so on. So whether it is the field of mechatronics, industrial maintenance, aviation maintenance, electrical, renewable energy, HVAC, marine technology, automotive, our software can help you in multiple aspects of engineering. The key benefits that software offers for students, they can validate the theories through simulation, and better have understanding of the behavior through dynamic color animation, reinforce their understanding through system interactions, and they can test the circuits virtually. For teachers, it facilitates them to demonstrate system virtual systems. It can be easily integrated into the course content, and as being a very user-friendly software, it can be easily handled by both teachers and students. For the institutes or school, it eliminates the need of purchase of single technology software. Different departments can work in conjunction and often eliminates the need of purchase of expensive, inaccessible hardware. Automation Studio can be used for e-learning or remote learning. So Automation Studio can be accessed through school or from home. You can create some scheduling, set some priorities for teachers and students. Suppose you have some exercises you want students to complete in stipulated time. You can also configure some time restrictions and access points. We are available in 11 different languages and sold over 120 countries. So the software is being used by high schools, career centers, colleges, universities, workforce development. These are the popular books on fluid power, like Anthony Esposito, Introduction to Introduction to Hydraulics for Industry Professionals, Electro-Hydraulic Components and Systems. All the circuits in these books are ready to simulate in the software. So you can directly open the file and simulate and analyze the behavior. Automation Studio also offers interactive exercises where we have built-in exercises which are very customizable, and often you can also create your own customized interactive exercises. So this can be used for evaluating the understanding of the students. The Automation Studio helps you create the virtual twin of the hardware into the software, wherein the students can, or teachers can change different properties, have better understanding of the interaction of the different components in the circuit, and later on they can use this experience to work on actual hardware, which could be more safe and reliable. We have illustrated libraries in the software. Illustrated libraries give more visual uh, the appearance of the component, how it looks like in the real life, for better understanding for the students, wherein they can compare the ISO symbols and the actual 3D of the component. The benefits for, so if you go for a hardware, there are often limitations where a limited number of students can be trained on particular hardware. But if you have hardware plus Automation Studio, the students can have access to the different circuits. They can have better understanding of the interactions of the components, the impact of the properties, and then later on they can use it onto the hardware. It also enables students to circuit design software. Students have idea about ISO symbols and helps them read blueprint reading skills. Yeah. So in addition to these features, Automation Studio also offers manufacturer's catalog. What are manufacturer's catalog? Manufacturer's catalog consists of pre-configured, ready to simulate with exact manufacturer specific data. All you need to do, configure the product from the catalog and drag and drop it on into your schematic and use it in the system integration. So with every such product, you will find a test bench attached to it. So for an instance, you're looking at the screen, this is a reducing valve and the manufacturer behavior associated to it, and some testing scenario where you can test the behavior of the component and be sure of its behavior and manufacturer specific data. So we have manufacturers catalog for different manufacturers like Emerson, Boss Rexroth, Danfoss, Tucson, Eaton, Hengley, Genetics, Parker, Poclane, Sun Hydraulics, UKIN, and so on. These are partial list of our industrial clients. So in the field of aerospace, we have Airbus, Boeing, NASA, agriculture, AGCO, CNHI, John Deere, energy, ABB, Hydro-Quebec, forest, John Deere, Kubota. Under construction, we have Caterpillar, Hitachi, defense, L&T, General Dynamics, metallurgy, ArcelorMittal, China Steel, mining, Epiroc, Komatsu. Offshore, we have BRMS, Cameron. Under transportation, Honda, system integrators like Arvi High Tech, material handling companies like Skyjack, Terex, and so on. So this was the brief introduction about our company and what we do. Let us start with the topics for the webinar today. So I'll switch to the another screen. Okay, so right now on my screen, you're looking at Automation Studio 7.1 version of the software. This is the interface of it. At top, you have ribbon bar with different tabs into it, like Home tab, Edit tab, View tab, Simulation tab, Failure Analysis tab, Fluid tab, Tools tab, Support tab, Demo tab, and Technical Training Material tab. Each tab over here has different features inside it. So during the webinar, we will look at some of them. On left hand side of the screen, we have Library Explorer, which will show you the different modules included in the software, like hydraulic, pneumatic, drive and transmission elements, environment control, electrical control in different standards, digital electronics, ladder logic in different standards, Allen Bradley, IC, Siemens, LS Electric, Mitsubishi, electrotechnical, IC, NEMA, electrotechnical one-line blocks, HMI and control panels. On right-hand side of the screen, you are looking at Project Explorer. This will show you the different projects that you have opened and the documents included in each project. At center, of course, we have a workspace where you actually create or build your schematic. Now let me tell you more about the library. So the library, in each module in the library is arranged in the form of tree structure. To expand any module, you just click on the arrow over here and you will find the components segregated as per their behavior into different folders, like pumps and amplifiers, proportional pumps, hydraulic actuators, actuated clutches, accumulators, cylinders, directional valves, proportional directional valves, pressure valves, sensors, and so on. So for today's webinar, we will be concentrating more on the pumps component. So when I further expand pumps and amplifiers, you can see the segregation as per their behavior further. So we have unidirectional pumps, unidirectional variable displacement pump, we have manual control pumps, we have load sensing pumps, swash plate pumps, and so on. Now let me tell you a detail of these components. Now to use it into a schematic, all you need to do is drag and drop it from the library. This drag and drop product is not just CAD, it has behavior associated to it. So when you double click on the component, you go into the properties. Here you can set the properties related to the component. So here we have a unidirectional pump with drain. You can see the properties like displacement, rotation, angular speed, maximum flow, maximum pressure, and so on. You can change the rotation direction by clicking on this, whether it is a clockwise or anti-clockwise rotation. You can change the simulation model type. So right now it is an idle mode, so there will be no losses. But if you want a better real life scenario, you can go for a leakage configuration wherein you can introduce some losses or efficiency curves. So let me show you how does it differ. So when you select leakage configuration, now you can see the image has changed, indicating the behavior. Once this is activated over from the simulation model type, you are able to enter the technical specification curves. In this technical specification curves, you can define the overall efficiency curve, which will in turn impact the losses. You can define the viscosity dependency curves and the pressure drop curve, which will indicate the losses with respect to the pressure. Or if you have efficiency curves, which most of the cases we do have efficiency curves provided by the manufacturer, you can see the images changed, and then in the efficiency curves you are able to enter the overall efficiency curve, volumetric efficiency curve, overall efficiency curve, and viscosity dependency. So this is generic curve right now, but if you want to edit it, you have the data with you, just click on the curve, you can copy paste it over here. So if you have data in Excel, you can directly copy paste it over here. So you can have different configuration or simulation model type for the pumps. Let me show you the different behavior through an already created file. So here on my screen, you are looking at different models. Let me just start the simulation. So here we have a pump without shaft. So here when you click on it, you can see you can define the displacement and the rate speed directly, which will influence the output flow. So here as it is an idle pump, you can just see all the flow is going, which is so 80 into 1200, which corresponds to 96 lpm, is going back to the tank, no losses. Similarly, if you have a shaft, but again idle pump, you can see again almost 96 lpm is going back to the tank. Here we have idle scenario. The pump displacement is 100 cc. The speed is 2000, so the output flow should be around 200 lpm, which is what I can see. You can see on the screen. So all the flow is going back to the tank. The output flow is going back to the tank. So as it is idle mode, no losses. Same goes with the pump with drain as it is in idle mode. But suppose as we have discussed before about leakage configuration, if I configure the pump for leakage configuration, there are curves inside it which will influence the losses. So here you can see the output flow should again be near by 200 lpm, but you can see there is a certain amount of losses, which is like almost 7 lpm for 140 bar. So there is 7 lpm losses. So this could be the internal leakages. Then we have a pump with drain. So there is an additional path for the losses through the drain. So here you can see additional loss. So as compared to the 193 lpm, because of these drain losses, there is 174. So again, you can see it is impacting the behavior. Here on the on the right hand side, you can see efficiency curves model. So efficiency curve model is directly impacting the behavior or the losses through volumetric efficiency curves and overall efficiency curves. So you can see some losses. Okay. In addition to the, you can, if you want a centrifugal behavior or rotodynamic behavior, you can also have a rotodynamic curve. So you can see it can just create some addition in if only the enough head. So if I have no pressure requirement at the output, you see the flow going, the pump is allowing the flow, but once I go beyond certain pressure, you can see the pump is not able to provide that much of head or the pressure, and the no flow is going up to the load over here. In addition to this, we have pressure compensated pump. Here, pressure compensated behavior is it should maintain the constant pressure at the output of the pump, irrespective of the load. So even if I change it, you can see it is trying to maintain 140 bar. We have electro-hydraulic pressure control pump. So here you have an additional command. Here, this pedal over here is linked to the solenoid over of the electro-hydraulic pump, which can control the control pressure at the output. So you can see when I'm changing the input, this control pressure is changing as per the input I'm giving through the pedal. So it is decreasing the compensated pressure. Similarly, we have a load sensing compensated pump. So as we know, load sensing tries to maintain a constant pressure drop across the orifice. So right now, in addition to the displacement rated pressure and setting pressure, it has additional property called differential pressure setting. So based on what setting I defined over here, it will try to maintain that much of pressure drop. So right now it is maintaining around 12 bar of pressure drop. So even if I change this orifice, it will still try to maintain this 12 bar pressure drop. So there are different models that we have in Automation Studio, and you can use it as per the requirement in your system. This was related to the pump. Now let us look into the proportional valves or direction control valves. Let me create a very basic circuit to demonstrate you that. So I'll take some components from the library. So I took a unidirectional pump. I'll take a reservoir. I'll take a 4x3 direction control valve, relief valve. Maybe I'll take a actuator. For actuator, I'm taking double acting cylinder over here. And yes, so basic components I can zoom all the components. So when I take my cursor to the port, it changes into target point. All I need to do is click on the port and connect it to the port of the component I want to. So I will quickly make the connection. To make the junction onto the line, you just have to double click. Relief output back to the tank, direction control output to the cylinder, and this port connected back to the tank. Okay, so very simple hydraulic circuit I have created. I can simulate this. So this is an on-off behavior. So when I just select the I need a drive to move this, run this pump. So I need to have some external drive. For external drive, let me take an engine over here. Okay, so you can see the cylinder is extending. I'm using as an on-off behavior of the direction control valve. You can also have a proportional behavior. I'll just take a copy of this over here, and I'll change the on-off valve into a proportional valve or a servo control valve. So here, when you double click on it, you see the properties associated to direction control valve, where you can set the properties. In addition to this, we have technical specification tab. When you click on it, it enables you to configure the direction control valve as per your requirement. So I can change the behavior from on off to proportional. So you can see the additional lines to indicate the proportional behavior of the valve has had been added. You can define the number of ports, number of position, initial position, neutral position, and so on. You can define the spool travel curve. So based on the input signal, what would be the spool travel, you can define that curve. You can define what would be the flow at particular position of the spool travel that is configurable. You can define the pressure drop curve. You can define this pressure drop curve. So force flow limitation curve, or define leakages between any port if you want to. Okay, so this is, I have converted this into a proportional valve. Now I can control its proportional behavior. Okay, so to have a proportional control, maybe I will have an additional joystick which can link it to the solenoid to proportionally control the position of this direction control valve. So I'll go into environment and control. I'll go select in joystick, drag and drop it, and I can double click on this and link this solenoid through variable assignment to the input signal proportional valve. Okay, so you can just see the description. So this variable I'll be linking with the joystick variable, which is when I default is JY. So when I type JY, it filter out the variable, and I'll just link it with JYX. Okay, now you can see when I give the input through this joystick, I can proportionally control the position of the direction control valve based on the input that I'm giving through the joystick. In turn, this is controlling the flow going through the cylinder, which will control the speed of the cylinder. So you can see. Okay, so in this way you can have a proportional behavior. You can convert the on-off direction control valve to a proportional valve, where based on the position or the spool travel, the resultant flow will be affected. Okay, now let us look into the load configuration onto the actuators. So I'll just delete this and just keep the original over here. Suppose I have a requirement wherein I want to have a constant load onto the cylinder. So some loading conditions that I want to have onto the cylinder. So you can double click on the component. Now when you double click on cylinder, it is showing all the properties associated to the cylinder. You can see the images indicating the different variables. Suppose I have an inclination of 45 degree and there is an external load on the cylinder of 1000 kg acting on this. Okay, so now this cylinder is subjected to some inclination and external load, which is a constant load. So this should require additional pressure to extend this cylinder. So maybe I can just take a measuring gauge, measuring pressure gauge over here, and just add it over. Okay, so let us try to simulate this. So you can see some pressure is required because of this load onto the cylinder due to retraction. It is in the direction of the gravitation, so it is not requiring high pressure, and there is some cavitation. But during extending, it is against gravitation, so that's why to lift that load, it is required some pressure. Okay, so this is a constant load that I have defined. But what if I want a variable load acting onto the cylinder? So for an instant, let me just remove this cylinder, take a fresh cylinder from the library without any load. And now this cylinder, I want to subject this cylinder to a variable loading condition. So to do that, I can double click again. So here in this, you have force curves. So once you click on the force curves, here you can define the curve, defining the for driving force curve or resistive force curve. So you can define a driving force curve for extension and retraction separately. Um, and if you want to have a resistive force curve, for an example, say suppose there is a spring that you want to compress and the resulting force will change as per your cylinder position extends. So suppose during extension I want to define a linear increase in the forces. So here you can see I have defined some resistive force which is increasing in nature with the increase in with the change in the position of the cylinder. So I have defined some curve over here. So this is a resistive force. Now when you simulate this, you can see this value is changing, this pressure is changing based on the cylinder position. During retraction, as I have not given no curve, so it is just constant value, but during extension you can see this is changing because of the nature of the curve that I have defined in the force curves. So this is another way that you can have this uh, load configuration onto the actuator. Let me just show you an example of where you can have say some such kind of requirement where you have to compress the sand. So this particular kind of resistance, because of compression of the sand, what would be the resultant pressure onto the piston side can be calculated or seen. So this behavior can be validated. I'll start the simulation and you can see this pressure as it is changing, the higher pressure is needed to compress it further, and you can see it. Now this particular behavior is because of the resistive force that I have created over here. So inside the properties we have resistive force curve, so you can see this resistive force curve. So in this way, based on the application that you're looking for, you can have some force curves configured inside the actuators. Let me show you another scenario where suppose instead of say a cylinder as an actuator, I have a motor. So maybe I'll take a motor. I've removed the cylinder, I'll add a motor over here. I'll just connect it over here, make the connections. Okay, now another way of adding load onto the actuator is through external command or a variable assignment. Say for an example, I want to have a resistive torque onto the motor through a pedal. So I can go in environmental control. Here I can select a pedal. Okay, so this pedal I'll link with the resistive torque of this motor. So for an example, I'll go double click on the motor. You can define the driving torque or resistive torque similar to what we have seen for the cylinders. Another way of adding the load is through variable assignment, where you have this resistive torque variable. So this variable can be linked with the external command. This is pedal in this case. So the default variable for pedal is PD. I'll just filter out it and I have linked it. So it will ask you in which unit you want to apply this resistive torque onto the motor. So maybe I am okay with decanewton meter. I'll just validate this. Now I'll start the simulation. So when I increase this pedal input, you can see this pressure is increasing now. This is because I have added a resistive torque onto the motor, which is controlled through this pedal. Maybe this can be considered as a braking pedal, which is increasing the resistance to the motion of the motor. So this is acting as a resistive torque. So this is another way how you can have a load configuration in Automation Studio. Let me show you one more way where you can have the load impact onto the schematic through mechanism manager. So here on my screen, what you're looking at is the mechanism that we have created using mechanism manager tool in the software. So here we have created this mechanism over here. Okay, so every body we have created, defined the joints or the motion constraint between the joints. So this is a rock body. You can see, you can define the body mass of this rock body. So these properties can be defined, and based on the linkages and the motion constraint type of joints between this motion will be impacting the hydraulic circuit. Let us try to say it. Okay, so you can see, let me try to lift it. So you can see this pressure is increasing as it is lifting it upper and upper. Okay, suppose I don't have enough pressure through this relief valve in the system, so this shall fall down. So maybe I'll decrease in this pressure. So you see this fall down because of the weight into the bucket. So rock weight is 100 kg, which is, and this pressure, I don't have enough pressure to lift this load, so I need to increase this pressure. So when I increase it, you can see this is extending up. Okay, so another simpler way of having the load configuration is through a mechanism manager. You can create mechanism and have its impact onto the hydraulic circuit. Okay, now we will look into the another topic that we have is mobile hydraulics related components. So mobile hydraulics specifically, we will look into some functions of pumps that we have. So you might have heard about the load sensing or pressure compensated behavior, axial piston pump or radial piston pump, splash plate pump. So in Automation Studio, you can also configure such kind of pumps. Let me quickly show you how you can do it. So in the pumps and amplifiers category itself, you also have the swash split pumps. So let me create a very simple arrangement for load sensing and pressure compensated pump. So here you see this is a different kind of symbol as compared to the gear pump over here. Inside it you can define the efficiency curves and so on, but in addition to that you can also define the swash plate or the swash plate cylinder parameters, the spring constraint, the force constraints. So you can see the piston diameter, rod diameter. You can define the spring maximum compression pressure, spring preload pressure, the stroke of the cylinder. So this all will influence the response of the or dynamic response of the pump, which is true in case of the swash plate pumps. So this can be done. Let me quickly create an circuit for load sensing pressure compensation. Here we have some hard-coded pressure compensator and differential compensator. Let us try to use this to create the function. I'm dragging, dropping it. Okay, you can change the orientation using shortcut keys. I'll just take, drop it down. I'll take a relief valve again for the load, and to control the flow I'll take a orifice. Okay, so I'll just make the connections quickly. I'll need a reservoir, so I can just copy the reservoir from the circuit. Okay, load output going to the tank. Okay, now I have this valve. This valve will control the flow going through the swash plate, so I'll be connecting this to the swash plate port, and this port will be going back to the tank. Now this port needs to read the pressure or the output pressure of the pump, or sense the output pressure of the pump. So I am connecting it to the same line of the output of the pump, and this pilot over here is to sense the differential across the orifice. So this is will be our load sensing the differential pressure control valve over here, and this is pressure compensator valve. You can change the function of the line. You can right click and change it to say load sense line. You can see the appearance has changed. Now to drive this, I'll just take the engine over here. Now the valves also over here that you see are configurable. So based upon what for path, what pressure drop you need, you can define the CV or KV value for each path. So you have like A, B, B, C path. So I can just change the KV or CV values, and you can see the behavior or the pressure drop curve has changed. So based on this gender completely is based on what behavior you require for the system, or what is the manufacturer specific behavior you're looking for. So you can do it for both the valves. So I'm just having some random values over here. Okay, now let us see whether this works as the here we expect for load sensing pressure compensated pump. And so I'll just start the simulation. Again, there are some tools in the simulation tab itself which can allow you measure different properties during simulations. I'll just want to see differential pressure across this orifice. Okay, now right now let me check what's the values of these valves. So when you click on this, it is 80 bar. Maybe this is pressure compensator pressure setting, so maybe I want it set around 250 bar. Okay, so you can see your pump is started to stroke again. Here, the orifice, maybe let me open it fully for now. So you can see pump has started giving all the flow to the load. You can see the load sense setting. Say I want to control a 20 bar across this orifice. Okay, now to activate this load sense valve, maybe I need to create some restriction. So I'll just decrease this orifice so that this pressure drop is increasing. Let me zoom out more for you. Okay, so I'm decreasing the internal diameter, which is in turn increasing the pressure drop across the orifice. Now, as I have this load sense valve over here, so now even if I further decrease this, you see it is still trying to maintain that constant 20 bar across the orifice. Okay, this is because of this load sense behavior over here. Now I can also check the flow going through this. So I can use the dynamic measuring instrument and measure the flow. Okay, so even now if I change the load, you will find that it is trying to maintain the pressure drop and the resultant flow is still constant. So this is the load sense behavior that you expect from a load sense pressure compensated pump, and this load sense behavior will be true until I reach the maximum pressure setting, which is 250 bar in this case. So once I go 250 bar, this well activates and your pump starts to destroke. You see the pump starts to decrease, destroke, and you can see that it does not allow the pressure to go beyond 250 bar, which is pressure compensated behavior. Now this we took the generic components from the library and tried to create the behavior, but we have manufacturer's catalog, and we can look to the another topic that we had for to today's webinar, like how you can optimize the circuit design through use of this manufacturer's catalog. Now let me just simply show you an example of a similar kind of pump, but which will be a manufacturer specific symbol and behavior. So for accessing manufacturer's catalog, you can simply go in home tab, open catalog manager. Here if you have the catalog downloaded, you can directly open it, and this is how it will look into the catalog manager interface. So let me show you a similar kind of form where we have a similar arrangement or the similar kind of functions. So this is a P2 P3 pump, a Parker specific pump. When you click on this, you can see this manufacturer specific symbol. Okay, you can configure this based on the requirement. So as we know, every component, manufacturer specific component, comes with a part number. So based upon your requirement, you can configure it through the configurator. This configurator is designed based on the manufacturer specification. I'll just quickly make the selection. And you can just select it from the drop down. Maybe this is torque control, load sensing with bleed off, and pressure control. So all three functions we'll be looking at in this. So I'll just quickly finish it out. Connection. So here you can see the exact part number now for this particular manufacturer specific pump. All you need to do is drag and drop it onto the schematic. Now you can see the let me just show you. Yeah, you can see the manufacturer specific symbol. all these parameters inside the valves and the efficiency curves are already configured inside this, so you need not worry about the behavior. You can also test and validate its behavior through the test bench. So in the section over here, you can see the data associated to the component, the image associated to the product, and in documents tab, once you click on this link, it will take you through the specification, manufacturer specification, which will give you details about the component, its behavior. You can check it, verify it over here also. And with every such product, you will have a test bench where you can test the behavior of the component. So I'm just opening this test bench so to show you how you can test the product. So here on my screen, you're looking at P2P3, which is pressure compensated load sensing torque control pump. In the shaded region, it's the manufacturer specific symbol. This is the efficiency curve associated to the product. So you can just simply follow the instructions, test its behavior. Now you can see the default setting is 145 cc, 350 is the pressure control limit, 35 bar is the load sense pressure, and the power control limit is 84 kilowatt. Now let us try to simulate it, see if it behaves as expected. So I can change this pressure. You can see the efficiency curve is followed. This is followed because we have configured the curves inside inside the pump, and this will be true until I enter the power control range, which is 84 kilowatt. So you observe this is at 72 right now, but when I go beyond 84, the pump is trying to destock, and this will not go beyond 84 kilowatt, which is the torque control or power control feature in swatch plate pumps. So this is a safety feature for your engine. So this is decreasing right now. You can see uh, it is not allowing it to go beyond 84 bar, and your pump is destroking. You can see over here, and this will be true until I reach the pressure compensated value, which is 350 bar over here. You can also check it from here. So 350 bar. Once I go beyond 350 bar, you can see it does not allow the pressure to go beyond 350 bar, and there is no flow to the load. So this is the safety feature where you don't want the actuator or the load to go or as subject your actuator to certain pressure above certain level. So this is 350 bar in this case. It also has the load sensing function. Maybe we can test it in other document. So I can just test the load sensing feature. I can decrease this orifice. So this should maintain 35 bar. You can see 35 bar. So it is maintaining 35 bar. Now if I increase this load, still it maintains 35 bar and a constant flow. So in this way, you can have a optimization of your circuit design through the use of the manufacturer specific components, which saves a lot of time and effort, if you try to create it from the generic component from the library. Let me show you another example. Let us see an example where I suppose I want to create a hydrostatic system. So maybe I can use some components from other library. These were Parker pumps. Let me take a component from Pokelin pump, maybe in a hydrostatic pump this time. So this PM series is again manufacturer specific series, PMV0. I'll go and select it over here. You can configure based on your requirement. You can just configure it quickly. So this way is similar. You just configure it based on your requirement. So just quickly, I'm selecting the options. Exact part number you can see right now. You just validate it. All you need to do is drag and drop it onto your schematic. So again, you can see how quickly I have created I have used a manufacturer specific product with exact symbol and the behavior. I just configured it and drag and drop it. Maybe I'll take say a Parker motor. where this hydrostatic drive is rotating a motor, which is Parker MR series. I can configure it. You can just quickly configure it and just drag and drop it over here. Okay, so I can complete this hydrostatic system through this. I can just rotate the orientation. This output is going to the motor and back to the tank. I can have these measuring instruments at the measuring ports over here. Okay, and to drive this, I'll take this engine. Okay, so simply I've created this, and suppose I want to have a load on this motor is rotating, say, a wheel. Let me add the orifice reservoirs first. So maybe I want to add a load onto this motor. I can just go into this and drive and transmission. Maybe I can have a mechanical gauge and then as a measuring instrument and add a wheel onto this mechanical gauge. Okay, so simply I can just have a pedal now to have a load onto this. So to apply the load, if you want to, let me just simulate this. When I enable this displacement, so I'm controlling the displacement on the pump. So you can see I have the hydrostatic system. This is PMV0 Poklin specific hydrostatic pump, and then we have Parker motor with specific behavior. So this really helps you to optimize your circuit design phase, or to have how the manufacturer component works, how the symbol looks like, a better understanding of the industrial blueprint circuits with ISO symbols and all. Okay, so just to confirm, you can see when I double click on this, I go in efficiency curve, you can see a specific behavior of efficiency curve. You see, so will all influence the output result of your simulation. Okay, so this is how you can optimize the system design phase through the use of manufacturer's catalog. Another topic that we have for today's webinar is related to the manifold, how you can create a 3D manifold. Let me use again the same circuit over here. Suppose I want to create a 3D manifold across this port. So let me just arrange the circuit. Okay. So for that we have some manifold tools. So in the fluid tab we have these manifold circuit tools where you can create this boundary line across the components for which you want to create a manifold. See, suppose I want to create a manifold across this port, this part of the circuit. Now we have manifold compatible catalogs where you can use the components from the catalog directly into the schematic. Say suppose I want to replace these two components with manufacturer specific component. Say again I can show you use of manufacturer's catalog. So in the home tab in the catalog manager, maybe now I will use another catalog. Say maybe Boss Rexroth oil control catalog, some components from the library from the catalog. So if I need a relief valve, so I'll take a say VS30 series. I'll configure it and just so I've configured it and just drag and drop it onto the schematic. Manufacturer specific Boss relief valve, and maybe a solenoid valve. I'll take a 4x3 position, size 8, VDS series. Again, I can configure this. Exact part number is seen, and I'll just drag and drop it. Now I will use this manufacturer specific components over here. These components are manifold compatible. I'll just You can change the rotation using shortcut keys like Control R. So I've rotated it by 180° and placed it over here. Now I've used to manufacture specific component. I need to create a manifold block across these components and these lines. So once I'm done with this, all you need to do is right click on this and create manifold circuit default connection ports. This will create the ports at the intersections of the lines. So you can see the ports have been added. Once we are happy with this, you're okay with this, select all the components, right click and say generate manifold. So I have created a manifold circuit. Now to enter or into the manifold ASLI manifold interface, you just double click on this icon. It will ask you in which unit you want to create this manifold. So you can either go for imperial or metric and just validate this. Now this is opening on my other screen. Let me take it to the main screen. So here, this is how it looks like, the ASLI manifold interface. Okay, now you can manually create it, or we have auto create function. So this will auto create the manifold based on the preferences that you have entered. So you can set the preferences in the current options. So here you can see different preferences that you can set. You can define the uh, the values of the clearances that you want for the manifold. So some standards that you can define. You can define the optimization standards, the block interface, hole closures, drilling sets, drilling rules, and all that. So based on this uh, options or the preferences that you set, if you go for auto create block, it will take into consideration all the preferences and go through an algorithm and create possible routing solutions for you. So here on my screen, it is trying to fetch different solutions based on the preferences. So you can see there are 100 potential solutions, and now whichever solutions is okay for you, you can go for it. So right now I'm just opening one of the solution that you see on my screen. I have, this is the manifold is created, and this is so easy and user friendly to create this manifold. Now this manifold is not just the 3D manifold, you can also simulate this. So on my screen, as you can see, the right hand side I have the manifold, and this is the hydraulic circuit. So I can start the simulation. So you can see the animation happening on both the screen. Now this is a manifold, so the routings or the drillings parameters will impact the pressure drop. So whenever you hover your mouse, you can see the flow, pressure, temperature. So you can see it in each line. So when I change this position, you can see the flow, the pressure. So you can measure this, you can see it, analyze it. So if you change any conditions onto the system in the, it will show your impact in the manifold too. Okay, so this is manifold creation, and let me stop this simulation and show you some additional features that we have with manifold. So in addition to this, you have the create the part list. You can see the technical data. You can create some technical drawings. So if you want to create technical drawing, it can create technical drawing for you. Just a second. Okay, so here you have the technical drawings over here. It's the same. You can use auto create function if you want to. It will auto create the technical drawing. So it is trying to, in just few seconds, it will create the views. Okay, you can see the technical drawing already created based on the manifold that you have created, and you can also create a production drawing if you want to give it onto the shop floor. It can create and give you the production drawing also. So it helps you in optimizing the manifold block generation phase, and helps you also analyze it better through simulation. Okay, now this was regarding the topics that we had for today's session. Now to show you the capabilities of the software, let me show you a few demo files just to show you how you can create industrial circuits or complex circuits. Maybe I'll just show you through demo file. I'll show you, say, mobile hydraulics, wheel loader. Just open this file. So here we have an example where we have created a tractor or a wheel loader system. You can see on my screen, this is a complete wheel loader application system where we have different kind of pumps, so closed loop pumps, open loop pumps, steering unit, braking units, priority valves, load sensing pump, control blocks. So all these components that you see on my screen are manufacturer specifics. Like this is a Soido and Foss closed loop pump, a Linde pump. Here we have again the Soido and Foss steering unit, Vapco valves, Safim priority valves, Bosch control blocks, Bosch pump. So this is, I'll just try to simulate it. So you can control the inputs through the joystick, through the commands that you have, like can control the current, and which in turn will rotate the wheel. You can see the flow going through the wheel. Similar, I can do it for the other hydrostatic pump. You can see it is rotating the wheel now. Similarly, you can have this steering unit. You can change the steering unit. You can see the steering happening. You have the brake pedal over here. You can apply this brake through this pedal. You can see the change in the force over here. The brake is being applied. You can see the cylinder changing its position. Similarly, you have a control block, and this load sensing pump is providing the flow to this control block. So I can change the current, which is impacting the pilot over here, to this valve, and the flow going through the load, which is motor over here. Now this motor is running at 1900 nearby 1950 rpm. I can apply load onto this, so you can see the pressure is increasing. Once I go beyond, say, around 250 bar, you see the motor stop. No flow is going through the motor because you have the safety relief valve over here in this control block, which is not allowing the pressure to go beyond 250 bar. So in this way, you can have a complete system created in Automation Studio, and such complex systems can be created. And if you have such system integration to be done, manufacturer specific components can really help you with this to optimize your design phase. Let me show you another example of an excavator. I'll show you through a video as we are limited time. So this is on my screen. You're looking at the excavator system, where you have a 3D also, which is this 3D is being linked to the hydraulics cylinder. So the motion that you see is based on the motion that you have in hydraulics. The loading condition or the mechanism will also impact the behavior of your hydraulic circuit. So if there is a change in the load or the body masses, it will have impact onto the hydraulics circuit. This is what we have already seen in the earlier part of the webinar, where we have seen load configuration through mechanism manager. So such kind of application circuits can be created in Automation Studio. This was all regarding the topics that we had for today's webinar. Just to summarize, um, We looked into the modeling of pumps, proportional valves. We had seen into the actuator components like cylinder and motors, and how do we have load impacts on it. Different functions that are used in mobile hydraulics like flow, pressure, torque control. We also saw an example of Parker P2, P3 pump. We have seen how you can optimize manufacturers, the system design using manufacturer's catalog. So we saw some Oakland hydrostatic pump. We saw Parker motors and Boss or Rexroth oil control components. We have seen 3D manifold block creation, and then we saw some demo files to give an idea about the capabilities of the software. Now, if we have any questions, we can address them. Okay, Sushant, Sushant and Sudhil, if you can come up with questions. Do we have any questions?
Yes, Vijay, we have two questions.
Mm-hmm.
So one from Mustafa that can we view the actual physical piston and actuators in our system?
We can see it, but that is very limited cats. So as we have discussed in the where I was introducing it to the through the corporate presentation, we have illustrated libraries. So when you see here we have a separate library where you can see the sectional components views, where this can help you see the cross section of the components over here. So maybe I'll use another one. Okay, so here you can have cross sections of different views. Say for pump, but this is limited animation that you can see on my screen right now. But the animations can be created in the software itself. So like relief valve, you can see it's the CAD or this will animate based on the connections that you have. So yeah, for some components we do have it, and but this can be created later on also. Let me see if I can look out for an example for you. So you can see on my screen. So this is done using the illustrated library. Okay. Yeah. So any other question?
Yes, so another question from Prakash that can we measure the linear velocity of the wheel attached to the motor?
A linear velocity. I doubt this can be done, but if he can elaborate more of his question, what exactly as a parameter we are looking for. Shushan, can we unmute him?
Yes. Hello,
Uh,
Prakash.
th- yeah, thank you, team. Can you hear me?
Yeah.
Yes, Prakash, yes, we can.
Yeah, so Vijay, I want to measure the linear velocity of the wheel attached to the motor directly. So I want to get the real-time values of the wheel for the linear velocity. So do we
Uh,
have any option to check that in Automation Studio?
Maybe we can use some calculation to do it through controller. If I'm not very sure which parameters will be helpful for this, but in terms of measuring the values, we we can measure some values related to the pump through dynamic measuring instruments. And if that values can be used in the controller through some calculation to calculate the renewal velocity, I guess that is one way that I can think of right now. But maybe I can check it on a better solution for this later on, and we can get back to you.
Yeah, that should be fine. I will get in touch. And the second query I have, Vijay, is regarding the time needed for the like cylinder in real time. Can we measure the time for uh, extending the cylinder from the piston side to the rod side completely?
Yes, again, that can be easily done through the controller. So we can measure, say, for cylinder. Say I have a cylinder, I can measure the speed of the cylinder, right?
Correct.
Right. So I know the stroke. I can measure the velocity of this or the speed of this cylinder easily. I can just calculate the time through the formula, distance upon time. Yeah. So this can be easily done through the controller. So may not be directly in respect to time, or maybe plotter can help you with this. So if you
I
drag and drop.
I tried with the plotter. With the plotter, I think I was not getting the real-time values. Something I was looking for. Um,
Okay.
I will check with the controller maybe.
Yes, and also if you have a specific requirement, well, you can let us know. We can work on that to
Definitely.
provide the solution that you're looking for.
Yep, yep. Thank you, Vijay.
Yeah.
We have another question from Patrick.
Hmm.
That can AS be used to remotely control hydraulic system in university's lab from home?
From home. Okay. Can yes. Okay. So maybe she's looking for the OPC connectivity kind of thing. So yes, we have features for connecting the automation studio to the hardware. It's a completely separate topic or the feature that we have in the software, where you can have compatibility of automation studio software with the hardware through OPC communication. So yes, it is possible. To answer in short, it is possible to have that connection between hardware and software. Any other question, Sushant?
No, Vijay.
Um, okay, so okay, so I don't see any other questions. So if you have any questions later on which comes in your mind, please feel free to get back to us. We'll be happy to address them. Maybe a one-to-one conversation will be really good. So we do encourage you to get in touch if you have any questions, or if you want any topic, a specific topic for webinars, we'll be happy to address that. Yeah. Yes, Anil, if you have any points to add.
Yeah, thank you, Vijay. So, am I audible now?
Yes, you are audible.
Yeah, yeah. So as mentioned by Vijay, if you have any questions or any queries related to the product or any concern, you please contact us through our entry@ethicagenetics.com. So finally, we are at the end of today's webinar. Hope everyone is good with the session. We have a series of webinar planned on the upcoming days. The next webinar is on 23rd May. Topic is electrical. For every session, we have a separate registration link. We request all of your peers to register and bring it to pay. Thank you. Thank you, Mr. Vijay.
Yep. Thank you. Thank you all for your time. You have a good day. Yes, Saurabh, we can end the session.